Hey there, welcome to the garage. So we're gonna have a little fun this weekend. I'm gonna run some weld beads and I'm gonna let AI do an analysis on them and tell me what I'm doing wrong. So I tacked up these, I had some coupons laying around and I tacked these guys up. And what I'm gonna do is I'm gonna do stick weld on one, MIG on the other, and TIG on the third. And then I'm gonna let AI analyze those and tell me how I'm doing. So this will be interesting to see what it comes back with. It should come back and tell me that the wire speed's too high and maybe I was moving a little too fast. Definitely turned out cold. Let's see what AI says. Let's shoot a picture up to AI, ChatGPT, I guess, and let's see what it comes back with. What do you guys think it's gonna say? So here's the picture we're gonna get for number one. You guys take a look at that and tell me what you think. I'll post it up there while I'm firing up the chat. Analyze this weld. And let's just upload that same photo that I just took. And boom, let's see what it says. Looking at this MIG fillet weld on a T-joint, here's my assessment based on the visible weld profile. A visual inspection cannot verify penetration or internal fusion. Overall rating, 7.5 out of 10. Okay. Straight bead, travel path is consistent with very little wandering. Uniform width, the bead stays fairly consistent. Good ripple pattern, the bead has a regular stack of dimes appearance. Cool, no obvious porosity. Reasonable heat input. I don't know that I'd agree with that. The heat affected zone is even and not accessible. Areas to improve. Cold lap, lack of toe fusion. There we go. The weld appears to be sitting slightly proud of the base metal, especially where it meets the vertical plate in several places. The bead doesn't seem to blend smoothly into the vertical member. This can happen. Voltage too low, wire feed a little too high, travel speed a little too fast. So I was right in the fact that in how much I don't know how to weld. Cool. That's how you learn, right? Overall impression. For someone practicing MIG, this is a good looking weld. Your consistency already, you know what? You guys don't need to know that. This is just kind of boosting my ego a little bit, going, hey, you're doing good, keep trying. But that's what I suspected it was going to say. Voltage too low, wire feed too high, travel speed too fast. Cool. We'll let this cool, flip it around to the other side, and I'll crank the voltage up, get some more heat, and maybe back the wire speed down just a little, see if that one comes out better. Something to note, I'm getting a little bit more spatter than I would expect. I wonder if I've got a gas issue. I don't know, maybe a leak. I don't know. Let's go ahead and take this picture. I'll show you guys. This is number 2. Boom. So now we're going to come back to here and we're going to say the same thing. Analyze this. Analyze this MIG weld, please. Overall rating, 8 out of 10. What improved? Good consistency, travel speed looks steady, bead stays uniform, better fillet shape, uniform ripple, spacing. Areas to improve, spatter, most noticeable. There's considerable more spatter around your weld than the first example. Yes, I thought the same thing. Voltage slightly low, or possible causes. Voltage slightly low for the wire speed, stick out too long, dirty material or nozzle, contact tip beginning to wear. Fair, right? Okay, that's not a bad idea. I'd start by shortening the stick out. Yeah, I think I was running a little long there. 3/8 to a 1/2 inch, make sure the nozzle's clean. Start of the weld, the left side has a large cold start with a rounded blob. Yes, it does. That's very cold, I agree. This usually happens. You hesitate before moving. Your machine is building the puddle before the travel begins. Okay. tie into the vertical plate. Let's go to the summary. How about that? Overall, the weld was better consistency than the first, better bead size, better overall appearance. The main thing holding back is the amount of spatter in the cold start. Agreed. Travel control, 9 out of 10. Fillet profile, 8 out of 10. Start to stop, 7 out of 10. Cleanliness, 6.5 out of 10 because of the spatter. And bead consistency, 9 out of 10. So not bad. One question that would help narrow down the cause of the spatter, are you using solid wire with 7525 or are you running flux core? Good point. Because it almost does kind of look like flux core with all that spatter, but it's not. I'm not going to answer that question. So for number 3, we're going to run some 7018 rod. We're going to run that at 100 amps. And let's see how this works. Probably going to come out cold. This is pretty thick metal. We'll see how it works. It has been a little bit since I've tried to stick weld, so we'll see if I can even strike an arc, right? Number 3, this is a 7018. That's horrible, right? Everybody sees that. Let's see if AI can come back and even give me any kind of clue what I did wrong. So many things. Analyze this 7018 stick weld. We'll at least give it that much. So, oh, it's going to have a field day with this, I'm betting. It should, because that's awful, right? This is awesome. Based on the single photo, this does not appear to be an acceptable 7018 fillet weld. It shows several visible defects that would likely fail a visual inspection. For most structural applications, a visual inspection alone can't confirm internal soundness, but can identify obvious surface issues. Overall rating, 3 out of 10. I completely agree. It was awful. Severe porosity. I won't read all the details there. Heavy spatter, irregular bead profile, possible lack of fusion. You think? Poor starts and stops. Okay, keep the arc short with 7018. This is my suggestion for improvements. Almost dragging the flux coating. Yeah, I had the arc really long, but it was starting and stopping on me, so I think my rod may be bad. Clean both pieces. I had that. Store the 7018 rods dry. Moisture is common cause of porosity. That's what I was suspecting. If you're using 1/8 7018, verify your amperage is in the right range, which I don't think I was. I was 100 amps. So I was too cold. So if this was a weld test, it's just red X's all the way down. Surface porosity, irregular profile, possible lack of fusion, excessive spatter, you suck, you're fired, go home. All right, we're gonna try this again. I am gonna use the same rod so that there'll be some consistency there. Cranked it up to 115 amps. So let's, the piece is still a little warm, so that's gonna affect it a little bit, but we'll see. Wondering if these rods are a little, they're 7018, so they may have some moisture in them.
Come on. Ah. Come on.
Oh gosh, this is an awful weld.
It's funny. Ooh. There we go. Jeez.
I think my rods may have some moisture in them. So I got number 4 cleaned up. Boy, AI should have a field day with that. Obviously, so many things going wrong there. It'll be interesting to see if it points out the starts and the stops. It will, but maybe it'll give me some indication of why the arc kept dying. I don't know. That'll be fun. I did improve. I got a 5 out of 10. So better puddle control, Bead's more consistent, appears you maintain a stable travel speed, heat affected zone is relatively even. I got porosity. Yes, I do, a lot of it. There's several visible pinholes. These are rejectable in many welding situations. Slag inclusions, yes, because I started and stopped. Excessive spatter, uneven tie-in. What did you do better? Better arc control, more uniform travel speed, more consistent heat input, improved bead appearance overall. Yes. Suggestions. Keep the rod almost touching the work. I was all over the place. Maintain an arc length no greater than the diameter of the rod core. Wire. Pause slightly on each toe to improve fusion. Yeah, I wasn't really moving. I was just kind of straight dragging. Chip and wire brush thoroughly to make if you're making multiple passes. I didn't do that. Keep the 7018 rods dry. Moisture is a common cause of porosity. So yeah, it's basically telling me everything that we know already, right? Bead profile, consistency, porosity, spatter, fusion, starts, like all of the things. So fairly accurate in telling me how bad I suck at 7018 welding, at least in this case. All right, on to number 5. We're going to TIG it, getting tiggy with it. Gonna run 110. Yeah, that was a bad joke. 110 amps, and I'm using a 3/32 blue tungsten. I'm using 1/16 filler rod and a number 6 cup. So the Art Captain MiG 200 is lift TIG. It's not a pedal. So let's see if we can get this working. I went ahead and turned this piece around. This AI should come back and tell me that I was running my amperage way too low. I kind of tried to finish that out, but it was horrible. So I flipped it around to this other side. I'll get that marked up. I need to maybe clean that up a little bit more. Crank this up to 190 amps, and let's see if that does better, because that was, man, I was odd. It'll be interesting. Surely AI can pick that up, right? It's different. My TIG welding in my last video was a heck of a lot better than this. Okay, this one really should be funny. So this is number 5. This is my TIG at 105 amps. I'll show you guys what I'm gonna upload there. We'll jump over here. This was comical. That's how bad it was. Okay. Analyze this TIG weld. Number 5, photos. Come on. What are you doing? I'm out of uploads. Really? Okay. Well, yeah, so when you don't pay for ChatGPT, you can only do so much, whatever. Yeah, so we all know, so number 5 was TIG. I was running at 110 amps. That wasn't even welding. I mean, I was just irritating, kind of pissing off the metal. With number 6, I mean, that turned a little bit more into something kind of horribly inconsistent. Just like arc length and process and just my technique, everything. But it was way, I mean, at least it actually did something as opposed to number 5. So I hope you guys found this video at least a little bit entertaining. Use AI to help you learn how to weld. It'll be a thing. Hit the thumbs up if the video made sense to you, if it's something you like, and subscribe if you want to see more of my nonsense. And other than that, I hope you guys have a great day, and I will see you later. Thanks for watching. So AI aside, what I'm learning is that when I was TIG welding last week, it was quite a bit thinner material. This is really thick, and I'm learning Once again, TIG welding's really hard.